Obesity is a growing concern. According to the WHO, in 2014, more than 1.9 billion adults were overweight, of which 600 million was obese. This is a problem because obesity increases the risk of other diseases: cancer, stroke, and diabetes. Current drug therapies aren't very effective at promoting weight loss. What is effective is a surgical intervention known as gastric bypass. This is invasive, expensive, and not exactly a practical solution, which leaves us with lifestyle interventions, things like dieting, which some of us may be familiar with. Of the diets, high-protein diets are the most effective at promoting weight loss, improving body composition, and decreasing your appetite. However, they're not the easiest to stick to. Therefore, if we can understand the mechanisms by which they bring about these beneficial effects, maybe we can exploit them. Maybe we can hijack them and make our body believe it's on a high-protein diet, gaining all the benefits, without actually going on it. This is one of the aims of my PhD. Now, when we eat protein, it is broken down into amino acids in our gut. These amino acids can be detected by sensors, one of which is the calcium sensing receptor. Now, research has shown that it is located in specialized cells of our gut. These specialized cells are able to secrete chemical messengers which make us eat more or make us eat less. And something we have found, amongst other departments, is that if you activate this calcium sensing receptor with amino acids, it actually leads to the secretion of a hormone which makes you eat less, which makes it quite an interesting target for anti-obesity therapies. Interestingly, sometimes when we eat, the amino acids also enter our circulation and go to our brain, which is another area where this receptor can be found. Now, I have found that it is located in the arcuate nucleus. The arcuate nucleus is an appetite-regulating center of the brain, and it is special because it receives signals from all around your body about your sort of nutritional status and is able to generate a response which is appropriate. So, for example, it might receive signals about how much fat you have and tell you, okay, you need to stop eating and maybe, burn a bit more energy. So, the role of the receptor in this area of the brain isn't well known, and that's something I'm going to investigate. To do so, we're going to inject a virus into the brain of mice directly into this area. And what this virus is going to do is going to essentially genetically modify it to delete the receptor. And like this, we'll be able to determine what function it has. Will these animals still respond to high-protein diets? And how does this affect appetite regulation? All of this will be in the hope of identifying new anti-obesity therapies. Thank you.